Okay, so this session is 1.1 graphs of equations, and this should help you with, I think, 3 of the questions on the assignment for this week. So, I forgot to change my finding little new icons there. 1.1 covers sketching graphs of equations, identifying x and y intercepts of graphs of equations, using symmetry to sketch graphs of equations, writing equations of circles, and then using graphs of equations to solve real-life problems. So I'm going to just start with some terminology. So if you have a relationship between two things, we usually express that relationship in terms of an equation, and we'll have two variables because there are two things that are related to each other. The solution to an equation in two variables is an ordered pair. And for an equation in two variables, there are actually multiple solutions to an equation. So basically, any ordered pair that you can have when you graph the equation is a solution. And so then with the graph is all points that are solutions to the equation. So any set of values, x and y, that work in the equation is a solution. And when you would graph those and then connect it, that creates a graph of the equation, and anything on that graph is a solution. So I'm going to just start with, does 1, 2 lie on the graph of y equals the square root of x minus 2? So lying on the graph, asking if it lies on the graph, is the same thing as asking if it is a solution. So what you do is you plug in your ordered pairs, or your ordered pair, and then you see if the left side is equal to the right side. So we're given an ordered pair here, 1, 2. The first number is always x. So this is telling us that x is equal to 1. And then the second number is always your y. So this is telling us that y is equal to 2. So in your equation that you're given, you're replacing y with 2 and x with the 1. And then you're following the order of operations on each side of the equation to see if you can get the same number on both sides. So we have y equals the square root of 5 minus x. So y is equal to 2. And then I have my square root of 5 minus an x is equal to 1. So I need to simplify the right side by following the order of operations and hope that I get 2. So I have 2 equals. And when we're following the order of operations, we have to subtract first inside the square root. So 5 minus 1 is 4. So that's going to be the square root of 4. And when you take the square root of 4, you get 2. So we end up with 2 equals 2. So that, getting the same thing on both sides, that is a true statement. So that tells us that yes, 1, 2 is on the graph. Because we got something that's true. If it was not on the graph, you would get something that's false. And so it is a solution to that equation. And we can always check by graphing the equation. So I'm going to just pull Desmos over. And I'm going to click the Start Graphing button here. So I'm going to put in my equation that I was given. Y equals the square root of 5 minus x. And then we want to see is 1, 2 on that graph. So I can scroll in. 1, 2, you can see is right in this area. And actually, if I plot 1, 2, that you can see that the dot is right on the graph. So that means that it is a solution. So that's a way to check your answer, is after you do the algebra, you can also graph it and then plot the point and see if it hits that graph. Yeah, Brad, you have a question.
Yeah, I don't remember seeing this graph. Maybe I just didn't find it, but can you go back and show me how to find that again?
Sure. So the website is desmos.com. So it's DESMOS. And so I'll just, so it's this online graphing calculator. And so then you just click Start Graphing. And then you can enter in your equations or anything you want to graph right here. And so you can do a whole bunch of things with it. And I'm going to be using it multiple times in this session because a lot of what we're working on this week is graphs of equations. And then if you ever need help, if you're not sure how to use it, there's this help button right here. And so there are tutorials to help you learn how to use it, how to put in tables of values, a whole bunch of things. So that can help you. Otherwise, you can just explore and have fun with it and see what there is.
Thank you.
You're welcome. Are there other questions? Okay, so now let's talk about actually graphing. So generally, if we're going to graph by hand, you graph by plotting points. And what you will do is either solve your equation for x or y. We usually solve for y. That's when it says isolate one of the variables, what it really means is solve. So I'm going to just say solve for y. Then we construct a table of values. And when you construct that table, you can pick any x values you want, and then you plug them in to find the y value. And then you just plot the points, the ordered pairs, and then you connect them. And that's how we graph by hand. When you're making a table, always make sure you're choosing negative values, 0, and positive values. So you don't want to choose just positive numbers. You want to make sure you're on both sides. And then one thing when you're doing graphing is you want to start paying attention to the different shapes you get for each type of equation, because later in the class, we're going to talk about how the way an equation works kind of forces it to look differently on a graph. And so knowing how an equation looks can help you know what it's supposed to look like when you graph it. So for example, here we had a square root equation. And if I go back to Desmos, find where it is, and I'm going to just zoom out. I can actually get it to click. There we go. So that particular square root equations always look sort of like this. Sometimes they go the other way. So if I had changed this to a plus, it goes the other way. If it didn't have that 5, it starts at 0. But one thing when you start getting into graphing is to start recognizing that if it has a square root in the equation, it's going to have this shape. The shape may be going left or right or be moved around on your graph, but at least the shape of it is going to be the same. So that's something that you want to just start paying attention to as we go through this section. When we get to week 4, that's where you're going to really need to know this. But if you start paying attention to it now, it will help you when you get there. So here I've got a second example. Sketch the graph of y equals 5 minus x squared. So we're going to do this by hand, and then we're going to use Desmos. When it comes to quizzes, you can use Desmos, and you don't have to do it by hand, but it's important to understand how to do it by hand just so you know what's going on. So when you're sketching a graph, the first thing we have to do is make a table of values. And if our equations solve for y, then we don't have to do anything fancy to the equation. So generally when we make our table, we plug in numbers for x, and we choose what numbers we plug in for x. We want to plug in negative numbers, 0, and positive numbers. The rule of thumb I follow is that you want to choose 5 different numbers, and so I usually choose -2, -1, 0, 1, and 2. Because that way I have negative numbers, I have positive numbers, I have 0. -1 and 1 are really easy to plug in. They're easy to do math with. And 2 is actually relatively easy to do math with as well. So those are the numbers that I always pick when I sketch a graph. But you can choose any numbers if you wanted. If you wanted to plug in -10 or -100, you could. You're just making the math a little harder for you. So you pick your x values, whatever x values you want, and then you put them into the equation. So on the right side here, my y equals 5 minus x squared. So I'm going to have 5 minus, and then my x is -2 for that first row. So I have 5 minus -2 squared. So I'm going to just keep moving to the right to kind of simplify this. So when you square -2, squaring a negative gives you positive. So that's going to give you a +4. So we have 5 minus 4, which gives us 1. So this gives me a set of ordered pairs, -2, 1. So your x is the first number, your y is the second number. Then you just do the same thing next row. So now my x is going to be -1. So I'm going to have 5 minus and then x squared. So x is -1, so that's -1 squared. When you square -1, you get a +1. So that's 5 minus 1, and that gives you 4. So we have -1, 4. Then we have to do the same thing with 0. It gets a little tedious. That's why I only pick 5 numbers, because if you do more than that, it gets sort of obnoxious. 0 squared is 0, so this is just 5 minus 0. So I have 0, 5. 5 minus 1 squared. My x is 1, so 1 squared is 4. I mean, not 1 squared is not 4. I really need to stop doing these things on Fridays. 1 squared is equal to 1. So that's 5 minus 1 equals 4. Apparently my brain was like skipping ahead and doing the math already before I was done. So now my x value is 1. 1, 4. And then this is a lesson of slowing down. Everybody needs to slow down sometimes. My x value is 2. 2 squared is 4, so that's 5 minus 4, which is equal to 1. And then that is 2, 1. So when you sketch the graph, you're basically just plotting these numbers. So 1, 2, -1, -2, and then 1, 2, 3, 4, 5. A sketch doesn't have to be perfect because it's just a sketch. And then I plot each of these numbers. So I have -2, 1, -1, 4, 0, 5, 1, 4, and 2, and 1. And then you connect those to get your shape. So if you were just trying to connect it, you get something that looks like this when you're connecting them. And that would be your sketch. And I put arrows because basically this goes on forever. The graph, when you graph an equation, it never really ends. It goes on forever. Now we can do this in Desmos. So I'm going to pull up Desmos, and I'm actually going to pull up the blank one here. And I want to enter in our equation. So I type into the box. I just type in y minus 5, well, y equals 5 minus x. And then to get in that exponent, there's actually, if it's shift 6, if you're looking at the keyboard, the little caret thing above 6 means you can get into the exponent. So I just hit shift 6, and that gets me in the exponent. And then I finish the 2. So that's our graph. And it has roughly the same shape as the sketch. And if I change, I can change the actual x and y where the axis how I'm counting. So if I match it, so this would be -2 for the x to 2. And then my y, let's just say -5 to 5. You can see it looks much closer to what I graphed because now I've changed the x and y so that it goes to the same spots that I counted to. And then I can zoom out and you can just see the shape. If you want to verify your sketch, we can plug in these values to make sure we did the math correctly. So we have -2, 1, -1, 4. And as I type all of these, you know they're correct if they show up on that graph. 1, 4, and 2, 1. So since every single one of these points that we found is on the graph, that means we didn't make any mistakes. So it's a way to check your work. And you can see that if you connected them, when we generally try to connect things with curves whenever possible, we get this shape. And then speaking back to trying to notice shapes, you want to notice anything with an x squared will have this type of shape. Sometimes it opens up, sometimes it goes down like this, but the shape of it is always going to be the same. Are there any questions? Okay. Okay, next is intercepts. So x and y intercepts are where our graph intersects with the x and y axis. So it crosses the axis, and that's called an intercept. So the x-intercept is where it crosses the x-axis, and in order to cross the x-axis, y is 0. And the y-intercept is where it crosses the y-axis, which means x is 0. And we always list our intercepts as ordered pairs, and you don't just give your list of intercepts. You need to say, this is the x-intercept, this is the y-intercept. So this picture shows you that, like the first graph, it doesn't cross the x-axis at all, so that doesn't have any x-intercepts, but it does cross the y-axis once, so that's one y-intercept. So you don't have to have the same number of x, the same number of y, and you don't have to have just one. In the second graph, we have 3 x-intercepts because it crosses the x-axis 3 times, but it only crosses the y once. In our third, it crosses the y twice, so there are 2 y-intercepts and 1 x-intercept. And then it's possible to never cross either one, which means there are no intercepts. So there are lots of different combinations of intercepts, and you can figure them out by graphing or solving. And we're not going to do the solving part, but we will do the graphing part. So if it says identify the x and y intercepts, identify means you're not doing any solving, you're just going to graph the equation and then list what they are. So we want to identify the x and y intercepts of y squared equals 4 minus x. So we do this by graphing. So I'm going to pull up Desmos. And I'm going to just make a new blank graph. And I'm going to type in the equation. And if you don't have a keyboard and you're still trying to get an exponent, if you click this show keypad thing, you can get a square right here. So I can just type in that, and now it's a y squared equals 4 minus x. Now I'm going to hide this. So this is what our graph looks like. When I had the x squared that we had on the previous, go back a couple slides, our x squared had that same shape, but it was going down. This equation, we have a y squared, And it has the same shape, but now it's sideways. So notice that the exponent, if the exponent is 2, it has a shape to it, but where that shape is depends on the equation itself. But at least it has, there's a shape to it that's the same. So when you identify the x and y intercepts, you're just listing where it crosses. And what's really nice is that Desmos tells us, because it has these little gray dots, and I can hover them. I don't even need to click them. If I just hover over it, it tells me the intercepts. So, and I can even click it. So we have a y-intercept of 0, 2, a y-intercept of 0, -2, and then an x-intercept of 4, 0. So when you say identify the x-intercepts, that's what you're doing here. And I can, actually what I'm going to do is take a screenshot of this so I can even put it in the slide. So I'm going to just take a screenshot. I'm going to copy that. I'm going to briefly end my slideshow just so I can, so let's see, I'm going to paste this into my slideshow. Start up my slideshow again. So when you're doing the assignment and it says to find the x and y intercepts or identify the x and y intercepts, you can take a screenshot of your graph and put it in your assignment, and then you can label them. So you would say, you can just label it like that's a y-intercept. This is also a y-intercept. And then this says an x-intercept. Or you can like write it down like y-intercepts are 0, -2, and 0, 2. X-intercepts are just, there's just one of them is 4, 0. So that's another way to show your work for that problem. But when it says identify, it just means graph it and then take a look at the graph and see what they are. And so the best way to show your work there is then to include the picture of the graph as part of your work. Are there any questions? Okay, so next thing is symmetry. This is a little harder for people. So we have three times. I don't know what I was thinking. That's supposed to say 3 kinds. 3 kinds of symmetry on a graph. The x-axis, y-axis, and the origin. You think of symmetry as like forming a mirror image. So if it's symmetric with respect to the x-axis, that means it's a mirror across the x. So if you drew a line halfway through at the x-axis, it's the same on the top and the bottom, but it's a mirror image. So that's the first picture here. It's a mirror, it's a reflection basically through the x. If it's symmetric with respect to the y-axis, the reflection is vertical. And so that's the middle picture. And then symmetric across the origin is a little more difficult to visualize. It's basically you're reflecting first across the x. So let's say I wanted to just take this right side. If I reflected across the x, that would be going down here. And then you reflect that across the y, and that gets me this portion. So if you took half of it, reflected it twice, that gets you the other half of the graph. So that's what it means to be reflected across the origin. It's confusing. But when you look at it, you can kind of see the pattern there. So those are the 3 different types of symmetry. When you're looking at symmetry graphically, you can either just look at the picture and say, okay, where's my mirror image? Or you can look at ordered pairs. So if the same x value has a negative y and a positive y, then it's symmetric across the x. So that's what this is saying on this picture. The same x has both a positive and the negative version of y. So that's what it means to have x-axis symmetry on a graph. Y-axis symmetry on a graph is that the same y value has the positive and the negative version of x on the graph. And then if it's reflective across the origin or symmetric across the origin, then if you have x and y, if you looked for negative x and negative y, you made both of those numbers negative, it would be on the graph. So we're looking in terms of negative values, whether it's present on both sides. Yes, Brad.
Okay, so the origin symmetry, you've got the curve that direction, you know, going up to the right, down to the left.
Yes.
And that is what the origin looks like, correct?
The origin is the center of the graph. So
that'd be 0.
That would be 0, 0. Yeah,
Right.
They call it origin symmetry because that's like the center at which it reflects on both sides. If you,
Okay,
it's reflecting over the x and the y, so they're just thinking, okay, center is 0.
Right, but so it's not a straight line.
No. You could, yeah. Actually, if you have a straight line, let me not use a highlighter. If we had a straight line, that doesn't go going through the origin, that is also origin symmetry. Because if, like, say, this was 1, 1, -1 is also on the graph. So a straight line could have origin symmetry. It all depends on what the graph looks like.
Okay, so the straight line is also correct, but then why would you have the curved?
The curve is based off of the equation.
Okay.
No, that's just an example. It's easier to see with the curve than to look at the straight line to really see the pattern.
Okay. Okay, got it. Thanks.
All right, you're welcome. So on our assignment, we need to test it. It says to test it using algebra, to do an algebraic test for symmetry. And so you do this by replacing y with a negative y, or replacing x with a negative x, or doing both. So this is best. I'm going to just do an example here. So we want to use the algebraic test to check for symmetry with respect to both axes, so the x-axis and the y-axis, and the origin. So if we want to test x-axis symmetry, we want to replace, y with negative y. And then that goes back to our picture. When on x-axis symmetry, we have y and negative y, and that gives us the same x value. So when you're testing, that's what you do. So our equation is xy equals 4. So instead of xy, it's going to be x times negative y, because it's x times y. Now I'm replacing y with negative y. So when I try to simplify this left side, I have negative xy equals 4. And then I want to kind of, you're basically trying to see, do you get the same equation? So our original equation is xy equals 4, but I have negative xy equals 4. Those are not the same. If the right side's the same, but not the left side. If I divided both sides by -1 to get rid of that negative on the left, I now have xy equals -4, which is not the same as the original equation, because the original equation has +4. So you're looking, can I get that same equation back once I've replaced y with a negative y? If you can't get the same equation back, then there is no symmetry across that axis. So because we can't get the same equation, we have no x-axis symmetry. Because if you try to get the left side equaling to match up, the right side doesn't. Or if you try to get the right side to match, the left side doesn't. When you're testing y-axis symmetry, it's the same idea. But you're replacing the x with negative x. And so I have negative x times y equals 4. And when you simplify that, you get negative xy equals 4. And we already know, because that's basically the same thing we got when we had the negative y, we know that that's not going to match. We can't make it match. So we have no y-axis symmetry. Then we want to test with the origin. And when you're testing respect to the origin, you're plugging in both x and y with negatives. So if you want to test the origin, replace x with negative x and y with negative y. And I don't have enough room for me here, so I'm going to just put this up here. So our equation is xy equals 4. I replace x with negative x. I replace y with negative y. And then I simplify. Here I have two negatives, a negative times a negative, so that gives me positive. So that gives me xy equals 4. And that is the same thing we started with, because our equation is xy equals 4. So we did get something that matches what we started, what our original equation is. So that means that, yes, we have symmetry. So this is symmetric across the origin. The reason why we're plugging in negative x and negative y is because we need to make sure that we get the same thing out no matter what x or y are. If you try to plug in a number instead of the variable, sometimes you could have both numbers on the graph, but it's still not symmetric. So you don't want to just plug in a number and hope it works, because sometimes it doesn't. So you need to use the variable in order to test it. And then you can reinforce your answer by graphing to see what the symmetry looks like. So we have x, y equals 4. So we don't have a mirror image across the x-axis, which is the horizontal, because we don't have the same thing on the top and the bottom just mirrored. We don't have a mirror image across the y-axis, because we don't have the same thing on either side of the y just mirrored. But we do have this mirror that's sort of reflecting on a diagonal, so to speak, across the origin, across 0, and that matches with our origin symmetry. And if I had taken this upper right part and I had reflected it down, it would then form a mirror image with this left side here, and that's how we know it's origin symmetry. So in a way, it's kind of a mirror across a diagonal rather than a horizontal or vertical. Are there any questions? Okay. For the assignment, there's actually an example in the book that is very similar. So I would definitely check out the example in section 1.1 about symmetry because it's going to be very similar to what you see on the assignment. Okay, so now let's talk about circles. So a circle is a set of points that have the same distance from the center of the circle, basically. So every point on the circle is like 2 away or something. If you're looking at it, you know, at an angle, it doesn't have to be up or down. And that distance from the center to a point on the circle is called the radius. So we have the standard form of an equation of a circle. The center is always h comma k. And then your radius is r, and so we have this formula, x minus h squared plus y minus k squared equals r squared. And I always recommend drawing pictures when you're doing things with circles because the assignment problem about the circle, oops, didn't actually draw. The assignment problem gives you a diameter. So that's twice the radius. So on the assignment, you need to find the center and you need to find the radius, but you're given the diameter. So if you look at it as far as a picture goes, that can help you determine the radius and then the center in order to get the equation. So we're going to use that equation. I'm going to rewrite the equation. X minus h squared plus y minus k squared equals r squared. And we're going to write the standard form of the equation of a circle with center 1 comma negative 3 and radius square root of 11. So the center, the first value is always h. The second value is always k. So I'm going to just plug this in. So it's x minus h, and h is 1, plus y minus k, and k is negative 3. And I'm going to put that in anytime I plug in a negative, I always put it in parentheses. So that's y minus negative 3 squared. And then our radius is square root of 11 squared. And then you want to simplify. So with x minus 1 squared, when you subtract a negative, that's the same as adding. So that's y plus 3 squared. And then when you square a square root, those cancel. So that equals 11. And that's your equation for the circle. And you can verify by graphing again whether you have that correct. So I have for my circle x minus 1 squared plus y plus 3 squared equals 11. So now I have my circle, and I want to see, okay, does it have a radius of square root of negative 11, center 1 comma 3? Well, it's kind of hard to tell in Desmos. So this is where I would bring up a second graphing calculator. There's this thing, another one I have a link to is GeoGebra, because this one actually allows us to do some geometry. So we have GeoGebra. It's geometry and algebra together. That's how they get the name. So I'm going to click Start Graphing. And this is great when you have things like circles, if you have shapes. Okay. So I'm going to do the same thing. I'm going to enter in my equation, x minus 1 squared plus y plus 3 squared equals 11. So it has the same shape, basically. But what's nice about GeoGebra is, let me put in the center that we found, 1, negative 3. I can, if you go over to this middle tab here, it can measure things. And this is what makes it really nice. So we can measure the distance or the length. So I can click that button to measure, I'm going to measure the distance from the center here. Okay, I'm selecting my center. Maybe I need to, why is it not? Okay, it's giving me the circumference. That's not what I want. It's like 2 points a segment. Okay. We might want to actually first add a point on this circle. Let's see. Okay. Actually, I've clicked the circle. I'm going to delete that. Nope, wrong thing. Undo. Where's my undo? Okay. I wanted to get rid of this A. Okay, click the circle. There, I have a point. My point disappeared again. I wanted to make sure I had a point on the circle. Okay, there we go. And my center disappeared. I don't know why that one disappeared. I don't use GeoGebra often. I only use it when I have to do geometry things. Okay, there's our center again. Let's try this again. I want to measure the distance between A and B. And then that should be equal to the square root of 11. And I can actually take the square root of 11 here. And there you go. So you can see, because our radius is square root of 11, it's 3.316624 and so on. And we get the same exact value here. This is the distance it's saying is between A and B. So this is verifying our equation. Because I graphed the equation, I took a point on the equation, found the distance from that to the center, we're getting the same radius. So it's a way of checking your answer. It's not an easy way to check your answer, but it is a way to check your answer to make sure your equation is correct. But I only use this particular GeoGebra when I have to do stuff with circles, because it's much easier. There's not really a way to measure distance on the circle here, and the circle doesn't even give you the center. There's not really a way to measure that distance. There's no measure button like there is here, where it has that distance or length you can measure. You can measure angles, which we won't need to do that, but there are some nice things that you can do here. Roots, it would be helpful when we get to week 5. So if you just want to make a little note to yourself, this would be helpful week 5. But other than that, I use Desmos for everything. So do you guys have any questions on the circle example? Okay, so that was all I had. I wanted to make sure I did examples that kind of hit everything that you're going to see on the assignment for this week and talk a little bit about it. Do you guys have any other questions for me on anything?
I'm good.
Okay. I don't see anybody typing anything either. Cool. Thank you guys for joining, and I will try to get this recording out and the PowerPoint out soon, so that way you can also use it for reference. Next week we've got holidays. I'm going to be traveling. I'm probably not going to end up having a live for next week because of everything going on, but I am going to try to at least have a recorded session that I will share with you guys. But it's just going to be, because we've got Tuesday and Wednesday off, and then I'm traveling. It's going to be a mess. So, because I don't even know like what kind of internet I'm going to be having at the hotels that I'm going to be at. So I don't want to try to have one and then have the internet that. So I'm going to try to pre-record one. But then the following week should be, back to normal, and I should be able to go back to having a live and everything. But I just wanted to give you guys a heads up. It's just too hard around the holidays. I kind of almost wish that they just gave us 2 weeks off and then just added 2 more weeks to the end of the term or something. But, oh well. So thank you guys for joining me on a Friday. I hope you guys have a great weekend. If you guys have questions, You know how to find me. You know how to contact me. And I hope you guys have a great holiday. If you're traveling somewhere, definitely stay safe. I know there's some crazy weather out there, so be safe while you're traveling.
You too, and Merry Christmas.
Merry Christmas. All right. I will talk to you guys later.